Today's notes are going to be pretty quick. We're going to be using the postulates and the pairs of angles that we talked about yesterday to prove that two lines are parallel. And it's basically by using the converse of each of the statements. Now, previously, those were postulates, and they are going to work as definitions for us today. And with definitions, the converse and the conditional were true. So we can use the converse in this case. If two lines are cut by a transversal in such a way that corresponding angles are congruent, then the two lines are parallel. And this comes directly from our notes yesterday at the bottom, where corresponding angles were congruent. Now, we do the same for the converse of the alternate interior angles theorem. If two lines are cut by a transversal in such a way that alternate interior angles are congruent, then the two lines are parallel. And just like we had the converse of those, we have the converse of the alternate exterior angles theorem. So, because those are congruent, then the two lines are parallel. Now, our last one was the same side interior angles theorem. For those, we said that they are supplementary. So if two lines are cut by a transversal in such a way that same side interior angles are supplementary, then the two lines are parallel. So we have our postulates that allow us to know whether two lines are parallel. Now let's actually go through and try a couple so we know how to actually use them. We're given angles 14 and angle 16 in the picture on the side here. So 14 and 16. Now both of those angles are on the same side of the transversal, so they're both to the bottom of the transversal, and they are both to the right of their lines. 14 is to the right of A, 16 is to the right of B. So that means that they are corresponding angles. And we know that they are equal, because that's given in the first part of our conditional. So we know that line A and B are, then line A is parallel to line B by the converse of the corresponding angles postulate. In our second example, we're given angle 6 and angle 10. So we find those on our picture on the side. We have 6 and 10. Now when we look at those, both of those angles, 6 and 10, are on the interior of our diagram. So they're along the transversal in between our two lines that we think are parallel. And both of those are to the right hand side of the parallel. So they are same side, interior angles. And in our setup, we were told that they add up to be 180. Now if we check our notes from yesterday, same side interior angles, if they're equal, then the lines are parallel. So that we know line N is parallel to line M. For 3, we have angles 3 and angle 6. So we go through, again, we find those angles in our diagram, angle 3 and angle 6. Angle 6 is the one that we had before. Now, both of those angles are on the interior, and they swap sides, so they're alternating. So we have alternate interior angles. And in our setup, we are told that they are equivalent or congruent. And that is enough to satisfy the converse of the alternate interior angles postulate. And that is what allows us to say that lines A and B are parallel in this example. Now, our last example, we have angles 4 and 15. So we find those in our picture, angle 4 and angle 15. Those are on the exterior, so they aren't in between our two lines, and they alternate. So those are alternate exterior angles. And in our setup, we are told that they are equal. So we know that lines M and N, the two lines that aren't the transversal, are parallel. The corresponding homework to this for tonight is 312. In problems 1 through 3, you just need to identify whether the lines are parallel, and then in the rest of the homework, you're actually using the the setup information to determine what the values of x are if the lines are parallel.